They did the sequence of the chimp genome and they compared it to the human genome, and what that paper said was that the data overwhelmingly confirms the hypothesis of common ancestry.
And it still has those two assumptions I mentioned.
Right? Now, the point
it still has the two assumptions I mentioned.
So hang on, let's suppose you change the probability assumption of the origination, for example.
Yep.
Right? So,
to closely one, what happens?
Right,
what happens?
Well, you'd probably have more types of life.
And what if it happens if transition probabilities become close to zero? Common ancestry is dread.
Sorry, second.
If the transition probabilities are close to zero, okay, let me ask you.
You can hang on a second. You can look at the way we assess things in science, right? This is universal in the scientific method, right? You have a hypothesis.
There is no universal scientific method.
All right, fair enough. But this is all right.
You know better than that. Come on,
okay,
you know better than that.
This is how we generally assess scientific hypotheses, right? They make predictions, precise predictions for data. Okay.
Using assumptions and theories they have.
No, but hang on. But you can validate those with the data.
I agree.
So you agree that general relativity is validated by data, right? Why do you think that?
Because it confirms what the theory predicts.
Right, so it made a very precise prediction, for example.
But no one denies that before looking at the data, you have an assumption, you have a theory.
Yeah, but the question is not whether you have assumptions. The question is whether your conclusion has to rely on your starting assumptions. Because if that's true, then you have a circularity problem. However, if you get to a point where the data could either confirm or disconfirm your theory, right? Then that data, then you can say, well, if it keeps coming back consistent with the data, then you have overwhelming evidence. That's what overwhelming evidence.
Yes, but that's still okay. But in this context, the origination probabilities and the transition probabilities are still there. And those assumptions, they affect what the data is telling you.
No. Okay, so let's take an example, right? Let's take an example of the human. What I was talking to.
Let's do transition.
Let's take the chromosome fusion prediction, right? Oh no, let's take another one. Let's take the nano P8 pseudogene, right? If it must be the case, right? Would you agree? It must be the case that if evolution is true, that nano P8, right, is the youngest pseudogene, right?
Not necessarily.
Why would it not be the case?
Because if we begin off, because you said necessarily, and that's the word I disagree with. If we begin off with different probabilities, that will change the entire tree of life and all of
but
them.
it doesn't.
Do you agree with that?
It doesn't change. It has nothing to do.
Okay.
Here's what I think. I think if we look at this piece of data,
you know, you're talking to that guy. What is his name? Chris. I'm going to give you two different scenarios.
Hang on, let me just make this point. Sorry. Okay. So if you have, let's take the nano PA. So just to explain, obviously you're filming this, right? I need to explain what the case is, right? So you have this pseudogene called nano, right? And what nano has is a bunch of pseudogenes. So these are genes that have been disabled, right? Now, if you look at human nano pseudogenes and you compare them to chimp human nano genes, what you find is they've got the same sort of malfunction they've got the same pseudogenes basically, so they've got like the same error, right? That in itself is evidence for evolution, because we think that
does that mean it's categorical?
Let me finish the argument, right? So, but it gets better than that, because there's one pseudogene that is unique in humans and it's not in chimps, okay? So, that nano pseudogene has to be the youngest one, right? So, if it wasn't, right, then you can't explain what. Well, let's put it this way: if human chimp common ancestry is true, you make the prediction that the one that humans only have, we couldn't have got them through common ancestry, right? So that must have evolved after the split, right? So not only must it be the youngest one, it must also be not just arbitrarily young. It must also be after the split. So if we think the split happened about 6 million years ago, then it must be, you know, if it was the youngest one but it was 10 million years old, then evolution would be in trouble, right? If it's younger and it's less than 6 million years old, then that's confirmed, right? This confirming will be older and not the youngest. Lastly, right, we think that the Neanderthal split with humans about, I think it's about 2 million. I had all this data when we did our debate, so I don't know off the top of my head, but I think it's about 2 million years ago, right? The point is, whatever it was, right, if it's more recent than the nano-P date, right, then it should be the case that Neanderthals have the nano-P pseudogene, the nano-PA pseudogene, right? So you've got three things there that could either support the hypothesis of common ancestry to be confirming, or it could be disconfirming. So if nano-PA was not the youngest, if it was older than 6 million years, and if it's not in the Neanderthal genome, right? So you've got three independent tests there, right? Every single one came back in favour of the common ancestry hypothesis. So when you get many things piling up, right, and all coming back in favour of the hypothesis, that's what we call overwhelming evidence.
Why I would say with that, that's an incomplete picture. Because if we make the transition probability close to 0 and the origination probability close to 1, then the separate ancestry hypothesis will be stronger than common ancestry. Because the transition probability was going to be close to 0.
It doesn't matter.
It does matter, Phil.
I don't think it does.
Okay,
right?
okay. Let me ask you this question. You gave this this example. The transition probabilities being close to 0 would mean that if we add the origination probability being close to 1, then you would get different implications on the data that you just highlighted.
No, but all you're doing is, right, so you're going like, you're trying to go from origin of life and trying to move forward using these probabilities. But the data, you can go the other way.
Have you heard of Sober's paradox on this?
Sober's paradox? I have to say.
If you did, then you would know about origination transition probabilities.
Okay. I did read Sober's book, but the point is, you can go
explain
the
the
other way
paradox.
around.
Can you explain the paradox?
You can go, no, I don't recall it, as I said. Right?
Shall I?
But yeah, go ahead.
Okay. So look, when it comes to origination probabilities and transition probabilities, these two probabilities are linked. You cannot deny, you can't separate out the two. And the problem is, in most of our discourse, we don't talk about transition probabilities, we don't talk about origination probabilities. So the problem that currently exists is this. Whenever you're talking about the tree of life, the assumption is that the origination event was unique. That's the assumption.
You have to assume that it's unique. You certainly have to assume, well, you don't, I think that here's the point. The question of what was the probability for the first life to form is a very interesting question. But if we're looking at this pieces of evidence for human-chimp common ancestry, we don't need to worry about what that probability is.
That's not true.
It is true.
No, that's not true.
No, it is true because the hypothesis makes particular predictions. Right. So let's suppose, right, you have, let's say it was 1 in a billion chance of the first life form evolving, right? But now let's suppose you change it to 1 in 2 billion, right? Now the prediction, whatever, it doesn't matter.
No, it does matter. I'll give you an example. I'll give you an example.
The prediction that you make for the nano-PA pseudogene date will be unchanged.
No, it will not.
How would it change?
I'll tell you exactly how it changes.
How it would change.
If the transition probability is close to 0, and the origination probability is close to 1, then you can have multiple origins happening, almost an infinite type, and you can have parallel lines of evolution, and you can have the hypothesis of separate ancestry being stronger than common ancestry. So everything is dependent upon. It does matter. It does matter. Are you telling me that the origination probability and the transition probability doesn't change the downward stream predictions you're going to make? Of course it does.
No, I don't think it does, because.
But you didn't hear about the origination and transition.
Again, you're making this about me. You look at the data, you look at the papers.
No, but if you don't know how the tree of life is constructed, how are we going to take your prediction seriously?
It's not because none of my predictions are born.
Yeah, so you should know the scientists are making these assumptions.
No. But the point is, those predictions don't change, right?
Even if you change the origination transition?
It doesn't matter, because.
I'll tell you why. I'll give you categorical evidence. I'll give you categorical evidence. Shall I give you a concrete example?
Let me just make this point, right? Okay. Let's put it this way, right? Let's suppose we wanted to know, right, if you and I shared the same grandparents. Okay? So, let's suppose we want to know whether you and I were cousins. Right? So all we need to find out is, do we have the same grandparents? Because if we're cousins, we must have the same grandparents, correct? Right? Now, if we change the origin of life probabilities, right, from 1 in a billion to 1 in 2 billion, does it change the fact that if we discover that we have the same grandparents, that you and I are cousins? Does that change?
I think that's a that's a disanalogy.
No, that is exactly.
No, that's
that is exactly.
No.
Does it? Would you agree?
It's a disanalogy.
All right, it may be a disanalogy.
No, it is a disanalogy. I'll explain why. I'll explain why.
One thing at a time. Would you agree that we can debate whether it's analogous? We'll leave that for the moment, right? But would you agree that if we establish that we have the same grandparents, then we can conclude, independent of whatever the origin of life probability is, that we are cousins?
Absolutely.
Right. Okay, so
that's a complete disanalogy, though.
No, but it is not.
I'll explain why. Can I explain why?
Go ahead.
Okay. The origin of life, probability being close to 1, would mean that there's multiple origins. So this analogy would not work, as in this analogy, there's only one origin.
No, there isn't only one origin.
So you basically concluded what you're supposed to be proving.
No, I'm not. Right. Okay.
Do you see why they're disanalogies there?
They're not disanalogies.
Okay, I'll explain why.
Hang on, you did just
if we are cousins and if we have grandparents, then that can be confirmed through independent evidence. That's what you're basically saying.
I'm saying is, if we confirmed that we shared a grandparent, then we must be cousins.
Right.
Independent.
Do you not see the problem? Do you not see how that's disanalogous to the origination probability?
No, it's not. Okay.
Well, you never heard of the origination probability before.
Again, you're making that about me. It's not about me.
No, because
all the papers in the scientific
if you don't know the
literature,
science, then how can you make these predictions?
Right, because I didn't make them. That's the whole point of it. I didn't. Other people did.
Then how can?
No, hang on.
Okay, so I'll give you an example. My friend here, just come here for a second.
Let me reply to you.
When he explained to you the evidence for common ancestry, did he explain it in a way that's probabilistic or categorical?
It's overwhelming.
Overwhelming evidence. But you never told my friend about the origination and the transition probabilities because it does matter. Let me explain to you why transition probabilities matter.
Let me explain why. Let me reply to it.
Have you heard of John Baptiste Lamarck and his independent evolutions?
Can I reply to your point?
Sure.
Yes or no? Right? Because it seems to me that what you want to do, right, is say, have you heard of this? Have you heard of that? Have you heard of this?
Because you're not learned on the topic.
Because it doesn't matter about me. You're trying to make this about me.
No, but you're speaking about the topic, but you're not sure about it.
You look at the papers, right? You look at what the papers. Everyone should do this. Go and look up the chimp genome sequence paper, published by all of the major genome sequencing population, and you should see what their conclusion is. The conclusion is that the data overwhelmingly supports human-chimp common.
Based on what assumptions?
Right.
Based on what assumptions?
No, hang on. One thing at a time.
No, based on what assumptions?
One thing at a time.
No, I'm asking you based on what assumptions?
One thing at a time, right? So that's what they're saying, right? So you want to make this about me, but it isn't about me.
Okay, fine.
But it isn't about
It's about the paper.
Right.
It's about the paper.
It's about the data.
What assumptions are in the paper? What assumptions are there for origination and transition? What are the assumptions?
I don't think it matters what the origin. That's the whole point.
It does.
Let me try and reply to your point about.
No. Let me respond to this point.
Okay, go on.
According to Darwin, he believed the power of natural selection was to be able to transform anything into anything else. So according to him, the transition probability was close to 1. And according to Darwin, and according to Richard Dawkins and other biologists, they believe the origination probability is close to 0. However, if we change that, if we change the origination probability being close to 1 and the transition probability being close to 0, meaning transition, we have different implications. Now, the other thing to keep in mind, something you said to my friend, is you made a distinction between common ancestry and the Darwinian mechanism, but these two are linked. If their mechanism breaks down, you cannot claim common ancestry.
I disagree. Because, okay, let's suppose that there was some other mechanism, right? Well, in fact, there are other mechanisms, right? We know that we have natural selection, but we also have genetic drift, right? So, there could be other mechanisms, right? Maybe ones we don't know about. The fact fact is that if you have, let's put it this way, right? I could do a genetic test and find I'm descended from my parents, right? Found that my parents are who I think they are, right? But it wouldn't tell me whether it was sexual reproduction or IVF. There are two different mechanisms that I could have been born, but it doesn't matter. It's just irrelevant, right? The fact is, if the genetic test comes back and it says they are my parents, I don't need to know what the mechanism of how I got here is. It just doesn't matter, right? So, common ancestry is not, I agree there's a relation between, natural selection is the popular method of how evolution occurs, but it's not the only method, certainly there are others, right? And some people say sexual selection is a different mechanism to natural selection, right? But that doesn't matter, right? Because you can do genetic, if you take the example that I gave, right, if it's the case that humans and chimps share a common ancestry, right, you can have different assumptions about these things, but you are still going to predict that nano-PA must be in the Neanderthal genome. Right?
Okay, so can I take what you're saying? Can I take what you're saying and change the variable?
Because we just have to go.
No, but last question.
Last question.
Look, last thing. If we change the transition probabilities and we change the origination probabilities and the mechanism itself, we say that it can't work. Say Darwinian evolution can't work, and the transition probability is close to 0, and the origination probability is close to 1. Then that means that separate ancestry makes a lot more sense than common ancestry under those assumptions.
Well, I would say that you're trying to go from these probabilities to common ancestry, right?
Oh,
what
separate
I'm
ancestry.
saying is that you can do these other tests, right, that are independent confirmation or disconfirmation, depending on what the data comes back as. And if the data comes back confirming, then you can just say that's enough. Right?
No, that's not.
That's enough.
If you were saying that, I wouldn't have no problem. My problem is you think the origination and transition probabilities make no difference to your conclusions.
I'm saying that these tests, right? If you change, let's say, the origin of life probability,
and transition is 0.
Right, you would agree. You'd agree that in the case of your grandparent, it didn't matter. You would agreed on that.
I already explained to you why that was a disanalogy.
You think it's not analogous. You think it's not analogous, but you would agreed on that, correct?
Of course, but that's a moot point.
Okay. Right, I'm saying it is analogous because just as you and I would be cousins if we had the same grandparents, right? So similarly, we and Neanderthals would share a common. Grandparent is just a common.
The point that you're supposed to prove, you've assumed.
No,
because we're talking about the same species and two different species.
No, but that's not the case, right? If it was the case that what I just assumed is what I got as a conclusion, right? Then you would have this circular argument. I would agree with you. Right?
No, but frankly, I think you don't understand those probabilities. I'll explain to you why. I'll ask you one question. Just one question.
Again, Subhoor. No, you didn't let me finish the point.
Go on.
You didn't let me finish the point. And I did say this had to be the last point, right? Because I do have to go.
Fine.
Right? So this is going to be the last point, right?
Sure.
The point is that you can get data that would, independent of what those probabilities are.
That's not true.
Right? Give you confirmation or disconfirmation. If it were the case that humans and chimps were not descended from a common ancestor, right, then there's no reason to expect that the nano-PA is the youngest pseudogene. There's no reason to expect that it would be in the Neanderthal genome. There's no reason to expect that it would be dated at lower than the split between 6 million years.
I get it.
All three of those things came back.
Can I do a logical symmetry? Can I do a logical symmetry on what you're saying?
You can, and then I'm not going to reply. I'm going to have to go.
Similarities are due to common descent, right? Could we not make a logical symmetry argument that dissimilarities are due to separate ancestry, such as orphan genes?
It's
logical symmetry.
We're not saying similarity. No, because we're not saying similarities or give us common sense. We're not saying that. That's not the argument.
What's the argument?
I already gave the argument, and if you didn't follow it, then that's your fault.
Do you have
I have to go. I did say 6:00. I had to go.
Okay, no worries.
It is now 6:45 almost.
Okay.
Thank you very much. It was very interesting. Cheers.
What he said to you before and now the transition and origination probability. Do you see the difference between the two now?
I don't want to hear.
Not funny about it.
This is a claim. This is a claim that I made.
Conclusions can
This
change.
is a claim that
Of course they do.
And if you change assumptions,
But you never heard of origination transition probability?
you said it best. I understand the concept.
Yeah.
And he completely took it for granted. And even when you change assumptions, he doesn't understand to change the data and the conclusion after.
It's just obvious.
You caught him at the end. He assumed his conclusion from the get-go.
Yeah.
So it was a complete disanalogy
Yeah.
because we're the same species when we're talking about cousins.
Yeah.
Versus when we're talking about the splits.
So right in the beginning, the reason why I went and spoke to him is because Ali Dawah said he wants to talk to you.
He disregarded that as well.
And he disregarded that. He disregarded that. So where's Ali? I need to talk to Ali. So anyway, Jazakallah khair for joining in. It's good because you went in there to speak to him first.
Where is he gone? My mic on.
Your mic, he's gone on the mic.
Oh my god, he took the mic.
Bro, Faithful, you did me a favor.
I know.
Because you went in there, you got talking, and I used that conversation. I said, why didn't you tell my friend that? Why did you only give him half the
You know what I did when they were talking about probabilities? I said, if you do respect the evolution,
Yeah.
I was like, you better pick up on that line. But you know what's sad about it? Someone smart as him, yeah? Does not understand the philosophy of science. He doesn't understand how the assumptions change the whole picture.
Bro, from the beginning, he didn't want to talk to me.
That's unreal. I couldn't believe how hard it was for him to accept that if you change the probabilities for transition that it would create an issue.
You're talking about the actual concept, the very important assumptions that change the whole picture. He's stuck in nuances.
Yeah.
He always does that though.
This is all relevant if this does not make sense.
Yeah. That's all I was saying.
100%.
Because look, if the transition probabilities are close to zero, nothing can transform to anything else because there's no mechanism.
Exactly.
If origination probabilities are close to one, which is John Baptiste Lamarck believed, you'll have millions of origins, millions of independent lines of evolution.
No common.
Just like delegation, handbrake,
no
that's
common.
it. If you don't look, it doesn't exist.
That's what they do, man. A lot of these science guys, they like to ice people out. Like, oh yeah.